like on Windows.
I opened hers up and I was just messing with some stuff, just looking through the files and stuff and seeing if I could
Hopefully.
do it on Mac.
This still works this way. Yeah. Okay, I'm screen sharing. I'm presenting to everyone. That's probably what I want to be. Maybe. Okay. Today, we are going to start really having fun. Well, yeah. Classes is where the fun starts. And arrays allow us to have even more fun. Hopefully you have already started thinking about this, right? But an array is just a bunch of things of the same kind. And many times we want to deal with bunches and not give each individual thing a name and things like that, right? Right now, if you have points, right? If you want to have 5 points, what can you do? Right? We have been using java.awt.point, right? If you want to have 5 points, what can you do? If you want to have 5 instances of the point object, what can you do? Well, actually, if you want to have 1 instance, what do you do?
Create an instance variable.
Create a variable, right? Create a variable and assign it to that instance, right? So point P equals new point 32 or something like that, right? Does that make sense? Now, what if you want to have 5 points?
Well, you'd have to create 5 variables.
You have to create 5 variables, right? And give them different names. Does that make sense? What if you want to have 10 points?
Just put them in an array.
Well, yes, that is the solution. Yeah. At some point in time, right, you just say, oh, I want an array. Is this thing gonna work? Maybe. Just create the plain Java project. Hopefully this created a class. No? Nothing. Okay. Yeah. So in here, I could do this. And keep going like this, right? Imagine that I want to create points in a diagonal line. If I wanted to create 10 points like this, what would I need to do? Keep cut and pasting, right, and modifying my names, right? Does that make sense? Does that suck? Yes. Okay. That's good. That's the motivation. Java and every other programming language basically provides us with the idea of an array. Many times what we want is to have one variable, one name for a bunch of things of the same type. Does that make sense? So I can, rather than have that, I can have a point array, and we use the square brackets to denote array. One variable, and I can do new. Actually, let me do this. Let me do it with int first. How about that? Int. When I am creating and initializing a variable, I can use the brace notation. And so I can use braces and then the elements in inside the braces separating with commas. Does this make sense? Let me eliminate for a second the points. This idea makes sense? We use the square brackets to denote that our type is an array of things, and we can use the braces. Once we have that, the array is an object, and we can ask two things of the array. One of them is its length. So we can do and another one is ask for individual elements of the array. And we use the square brackets to denote individual elements. Does this make sense? And this will allow me, hopefully, to run this thingy. Yes. The length of the array is 3. And the first element of the array is the number 1. Notice which number do we use for the first element. What number do we use?
0.
0. In Java, as in about half of the programming languages, arrays start at 0, right? When you become a programmer, you start counting 0, 1, 2, 3 instead of 1, 2, 3, 4. They lied to you when you were a kid. Now, it sort of kind of makes sense for programming to start counting arrays at 0, and so we do. Mainly for performance reasons. Other people start counting whatever they want. Normal people start counting at 1, and mathematicians, it depends on which field, I think, right? In programming, it is kind of everybody starts counting at 0. There's a bunch of programming languages that say, why should we do 0, and they do 1, but probably the majority do 0. So that is a very common mistake. Given this array, numbers, how many elements does it have?
3.
3, right? What's its length? Numbers.length is going to be what?
The length of the array.
Yes, which is what in this particular case? 3. What is the last element of that array? element number.
We counted like 0, 1, 2.
0, 1, 2. We end at 2, not 3. What happens if we do this of 3? Horrible things, right? Because that guy is not there. We're asking, give me the thing with number 3, and there is nothing there. There is no there there. Java is nice. It will raise an index out of bounds exception. Other languages will do horrible things like giving you whatever's in that location in memory. Chances are there is a location in RAM, and chances are that there are values there, and C will happily give you those values. That's not what you wanted. Why the heck did you ask? Java is nicer, and it will generate an exception and tell you kind of what happened. Does this make sense? Cool. One really cool thing about this is that we can do something like this. New int of 10, for example, and this will do 10 ints. And we can do sorry? It's a dot. It's the font. I have to call myself a period. Thank you. What does this do?
You're inputting whatever I is into the array.
Yep, I'm assigning whatever I is into the array, right? Does that make sense? And then I can later on do things like this. What would this print?
It would go through, start from 0, every element.
Yep, so what would this actually print in this particular case?
0 to 9.
Yep. Does this idea make sense? Let's create, since I like to make functions, a function print array that prints all the elements of an array. What would it look like? Yep, just like this, right? Except that our variable is called, our parameter is ARR instead of numbers. The numbers would make sense, but. What does our for loop usually look like for iterating over the elements of an array? What do we start with? Int I equals what? 0, right? And then we end up while we keep going while I is less than ARR.length. What would happen if we do less than or equal?
Out of bounds exception.
we eventually get an out of bounds exception, right? So instead of this, we can now do int array numbers. And we get the same number 0 to 9, right? Life is good. Although we don't always use this looping, Java gives us a way to iterate over arrays that is slightly nicer than this. In this, what are we doing actually? We are actually not going through the elements in the array necessarily. We are going through the indices, right? We are creating 0, 1, 2, 3, 4, 5. And then we are using that index to look into the array, right? Most of the time, 80% of the time, we don't really want to do that. We just want to look through the elements in the array. We don't care about the indices. We just have to use them. Does that make sense? In Java, we can do this. Instead of declaring a variable for the indices, we would declare a variable for the elements, and we would use a colon and then the array. And here, and just print the element. Does that make sense?
So is the colon a special like operator, or is it?
It's not an operator, it's syntax.
Okay.
It's like a brace or semicolons and things like that.
Is that the enhanced for loop?
Possibly. Whatever. It's the collection for loop. Yeah.
Okay.
I tend to call it the for each loop because whichever languages did it first called it for each. By now, almost every language has something like this. They just call it something different. The syntax is slightly different in every language, just to confuse you. But yeah, enhanced for loop makes sense. Does this make sense? Is this cool or what? What? Okay. It looks nicer. Two possible problems, right? One of them is that it's different than the for loop. The other one is that you don't have the indices. Not all the time can you do that, right? But for when you do, this looks nicer, cleaner, prettier. Now, let's do a couple of other interesting things. We can do, let's do this. About writing a function that returns true if the array contains that target element and false otherwise. What can we do?
For an element array?
Want to use this one?
Yeah.
Put braces. I should be putting braces. What do I do?
If at ELEN equals target.
Okay.
System out.
Wait.
Oh,
Am I printing? What am I doing?
returning.
Returning the value. I don't need to print a thing. What do I do?
return element or return ELE.
What do I return?
Oh, the index.
Not the index. What am I returning? Boolean. True or
Oh,
false?
true. Yeah.
Sorry? Parentheses? Oh, pfft. Thank you. Pair programming works.
Your mind's going to that.
Thank you. So that would, right? I'm going through every element. If I find it, I return true. If I get out of the loop and never found it, what should I do? Is this cool or what? What?
Does that still work if there are two targets in the array?
Yes, because when I find the first one, I'll return true and that's it. That's all I needed to do.
And
Right.
so it finishes once it returns.
Actually, how about we do count occurrences. Now we are going to return how many times we find that thing. What should I do? Okay, count. How about count? Yeah. This is kind of the second common pattern of array loops, right? We have an almost limitless amount of things we can do with arrays, right? But for the most part, we either go through every element and do something with it, right? That's kind of the first pattern, what we have been doing. This one is different because we are going through every element and accumulating some information into some other variable.
I have a random question from the
Yes.
original, from when it was doing contains. Let's say the number that I had was a Boolean instead, not a Boolean, but a float.
You can't. This is saying that it gets an int.
No, I mean, if the parameters had changed, it'd been a float. How far would it go before it said whether or not?
If we do this, that's what you mean?
Say I had two numbers, 7.34583, 93, and another that says 3457377. Would it check every single?
It is actually really, really weird. That is a great question. Floating points, and I have chickened out and not talked much about them, right? Floating points are weird. That's the thing. What do they represent? What's the best thing from that? They are scientific notation, right? You remember scientific notation. They tortured you with that in kind of middle school. 3.1 times 10 to the 6th, right? Why is that important? Why is that useful? Imagine that I ask you, what's the distance from the Earth to the Moon? Do you know the distance? Or what's the circumference of the Earth at the equator? Do you know that distance? Circumference of the Earth to the equator is 40,000 kilometers. Fine, that's how they define the meter. but it's not 40,000 kilometers with a metric thing, right? It's about 40,000 kilometers, right? What's the distance from the Earth to the Moon? Well, it's probably, I don't know. Let me just invent a number because I don't know that. 100,000 miles, right? If I tell you the distance from the Earth to the Moon is 100,000 miles, is that an accurate number?
Yes.
What happens with the Moon and the Earth?
It feels like a general number. It's not-
They orbit, they move.
They orbit, they move, right? And then which point of the Earth to which point of the Moon, right? They are about 100,000 miles, right? What does that mean? Well, that really means that it's closer to 100,000 than to 10,000, than to a million or to 10,000, right? That's what scientific notation lets you do. You can say it's 1 times 10 to the 5, which is 100,000, right? It's close enough, right? What I'm really saying is that it's between 10,000 and a million, which is a lot, but do I care if it's 100,003 miles? I don't give a hoot, right? At some point in time, I don't care about that level of accuracy. I'm not really counting, right? Does that make sense? Floating point numbers do the same. You have a bunch of bits represented for accuracy, and then a bunch of bits representing the exponent, right? Imagine that you were doing this kind of stuff in scientific notation. No. Oh. Never mind. BC doesn't do the notation that I want. Actually, probably Google does stuff. Google does everything. Right? At some point in time, right? I may do too many zeros. Does that make sense? In our floating point numbers, the same kind of stuff happens. I just broke Google. Just 60. It's enough to break Google. No, just 12 is enough to break Google. No, I think I wasn't pressing enter. I didn't break Google. I lied to you. Well, Google chickened out, right? And said, oh, I'm not going to print that many zeros. I'm going to tell you it's, right? And 90 zeros. Does that make sense? So what does it mean for two numbers in this notation to be equal? Is 1.3 E90 equal to 1.31 E90? Are they equal or not? Right? If I tell you that the distance from the Earth to the Moon is 100,000 miles and 100,002 miles, did I give you the same answer? Right? It's just like, floating point numbers are weird like that, right? There is an amount of precision, but saying that two floating point numbers are equal doesn't really make sense. And so for the most part, when you are doing floating point comparison, you should do, they are within this range. Does that make sense? So if we were going to do this, right, we would probably do it like this. Yeah. And from calculus, right, that thing is an epsilon. Weird Greek letters. Instead of comparing whether it's equal to the target, we would say it's greater than or equal than target minus epsilon. So that would allow us, does this make sense? That would allow us to call it like this, print and what's my problem? Tell me. Tab mismatch. Oh, never mind. I am an idiot. Yes. If I do this, right, I should get false, hopefully. I have 1.21, but I'm requiring an accuracy of 4 digits, right, of 10 to the minus 4. Now, if I do this, chances are that I will say that I do have 2.1, or sorry, 1.1, because 1.2, because I have 1.21. Does this idea make sense? Floating points are weird as hell. Just normal arithmetic doesn't work. Comparisons don't work. And actually, the stuff that you are used to with addition and subtraction and things like that don't work anymore, right? Because if you have 1.1, let's do this. 1.1, let's say E90, right? Plus 1. What's the answer?
You don't know.
1.1 E90. I lost that 1. Why? Because who the hell cares? You have 90 zeros. Who cares about one number? It's completely insignificant. But that means all arithmetic is weird. And that's how computers deal with stuff, right? Of course, normally we have double precision, have 64 bits total. And you have, there is actually a standard that tells you how many bits are for precision and how many bits are for exponents. And this is normally what you want, right? Especially for scientific notation, which is very different than accounting. For scientific purposes, right? 100,000 miles is close enough to the moon, right? When you're doing accounting, how much money do you have on your bank account? Would you be happy if your bank starts rounding up or down? Be happy if they start rounding up, but would you be happy if they start rounding down or rounding up your purchases, right? You want accurate stuff, right? If you're an accountant and you find that 2 pennies are missing, what do? Find those friggin' 2 pennies and figure out where is the error, right? Because that may be a big mistake. Normally, you as a programmer go nuts and say, like, here's a friggin' dime. Forget about it, right? But those 2 cents may mean something, right? And so when you're dealing with accounting, you don't do scientific notation. When you're doing scientific notation, you do, and you are used to math being weird. Does that make sense? Now let's go back to arrays. But yeah, we did another example, right? This would be count occurrences. And we were talking about it and saying we have an accumulator, right? We're accumulating how many times we did. We can do kind of the standard example of an accumulator is sum, right? Let's accumulate the sum. How can we calculate the sum of all the elements in our array? Count is horrible, right? Something like this, right? Sorry? For each element in the array, yeah. Oh, I am an idiot, you're right. It's not the sum plus equals, right? Yes, no, maybe. Cool. We can.
Do we prefer to do this stuff with loops rather than recursion?
You can do it either way. Arrays, everybody would just do loops because, yes. It's kind of natural to do loops over an array. And by the way, if you ever got scared in calculus about summations and things like that, and if you ever got scared in algebra about matrices and things, it is this stuff. Just with weird Greek letters. So you don't have to be afraid of math anymore.
Makes a lot more sense to me than like matrices.
It's really good to be able to see it in different ways and go from one to the other. What doesn't it like? and we get the sum. Does this idea make sense? Let's do one that's always fun. Let's find the smallest element of the array. What can I do?
I know it's similar to the bubble sleep.
Think about this. I'm going to tell you elements, and I'm going to tell you the array, and you tell me the smallest one. Okay? 1, 7, 13, -1, -2, 8, 7, 6, -3, 9, -2, 1. Which one is the smallest? -3, right? What do you need to keep in your head?
The smallest at the time.
All you need to keep in your head is this, right? That's the same thing on the computer, right? So int, let me call it smallest. What can we initialize it to?
The first element in the word.
Yes, right? What happens if I do 0? Well, if you give me a negative number, I'm doomed, right? I'm going to keep 0. So I need to do this. What happens if the array is empty? Oops. Well, on the other hand, what's the minimum element of an empty array?
0.
Not 0. Right? Maybe it's -100. And there's nothing there, so it's an error. So that's cool. We'll just error out. If you ask me for dumb things, I'll give you dumb answers. Right? It's not defined what should be the minimum. So it's cool to error out. We'll see exceptions, but does this idea make sense? We're going to start to this. Then what do? We could do this. Let's do it this way first. Then we'll see. We're going to go through every element in the array. What are we going to do? If the element is less than the smallest, what do? I don't quite need to swap, right? It's just lm equals smallest. And then at the end, oh, I did the wrong thing, right? The other way around, smallest equals lm. I'm changing the smallest. Does this make sense? Is there something that's bugging you? Now, there's something that's bugging me. We are considering the first element twice. I don't need to compare, right? So, let's use the other loop. Does this make some sense? You could have done the other one, it works. It's just slightly itchy because you're doing extra work. On the other hand, it's actually easier to write, so I don't know. But this allows me to do the next thing that I wanted to do better. this idea makes sense. This also tends to be one of the standard algorithms on arrays, and you get to do this 500 times. Now do the maximum, now do the, right? What else can we do? Let's do this. Let's do the index of the lowest element as opposed to the element. Does that make sense? Very similar, right? Smallest, let me call it smallest IDX. If this seems reasonable. Kia has been my conscience. I'm waiting for her to finish reading.
I'm sorry.
No, it is good. It is called pair programming. It helps. It usually helps to have other people looking over your shoulder, right? And seeing those kinds of things. Plus, my screen sucks because I need to do this so I can see. The angle at which I'm looking at my screen is terrible.
I like it.
Let's see if it may work. What do we expect to get? What's the right thing? We should get 0, 1, 2, 3, 4, 5, 6, 7, right? Which is the index of -2. Yay! We probably got it, right? On a real situation, you'd put more tests and verify, right? Test it with more than one value, but yeah, close enough. Does this idea make sense? Yes? Cool. Let me do this one is interesting. We'll probably do it a bunch of times. How do we swap two elements of an array? Swapping is, right, something done a lot, especially with arrays, but sometimes you can swap variables, right? What do you need to do? I'm swapping the elements on I1 and I2. Does that make sense? So what should I do? Can I do something like this? I need to close this, right? And then this correct. Yes, by the time I do this second line, right, I've already overwritten the original value of ARR of I1, right? And so I'm going to mess myself up. Does that idea make sense? Yes, to everybody? So what can I do? Create a temporary variable, write the old value there, right? Does this make sense?
Okay, everyone else, you have to look up and help them too, because we don't
Looks reasonable, right? We can pseudo test it. Let me do swap numbers. Let's swap number 0 with number 1, and then use print array. We should get 2, 1, and all that stuff, right? Yay. 2 and 1 instead of 1 and 2, right? Does this make sense? Some sense? Actually, let me introduce another useful thing that is very simple to see with arrays. The notion of the order of magnitude, right? The order of an operation. How long does swap take? Takes 3 operations, right? What if my array has 10 numbers? How long does swap take?
30 times.
No, my array, I'm still swapping 1 element, right?
Oh, yeah.
How long does it take? 3 operations. What if my array has 1,000,000 elements? How long does swapping take? Swapping 2 elements of that array take?
3 operations.
3 operations, right? So it's constant time. It doesn't matter the size of my array, right? It's constant. How about min and min IDX? What happens with those?
Take longer as the array gets bigger.
I have to go through every element in my array. So as my array gets bigger, I need to do more work. Does that make sense? We call that linear because I go through the array once, so it's linear on the size of the array. We'll see in a second how to sort, and there are much better ways, but I'll show you one that is quadratic. So I have to go to my array about the same number of times as the length of my array, so I end up with n squared, which is 5. Does that idea make sense? I'm going to show you the best possible way to sort. No, I'm going to show you the easiest possible way to write the sort algorithms. It's not the best sorting algorithm. In data structures, you will learn 17 sorting algorithms, and you will see this idea of O notation and how long do things take, right? But we're going to do a very simple sort. We are going to modify this guy to have a starting point. Does this make sense? So instead of getting me the index of the smallest element in the array, right? I'm going to get the smallest, but starting from somewhere else. That start, right? If I call min IDX my array and 0 instead of start, what happens? It's the same as our algorithm was. Does that make sense? So with this, what can I do? Well, find the smallest element of my array using this, swap it, so that now it's at element 0, and then do it again, but starting at 1. Does that idea make sense? So I can do I'm going to go for every space, right? I'm going to do int small equals in IDX of ARRI, and then swap actually just for, oh, well, actually, let me change. For a second, let me do print array. Instead of print line, I'm going to print the element and the space so we can print. Notice that in sorting, you don't print. I'm just printing so we can see what's going on. After the first one, right, we found that the lowest one was -2, and we swapped it from this one, right? Then we find the -1, swap it, and now the 2 is here. And we keep going until it's all good. Is this algorithm easy?
It seems easy when you're looking at it from a distance, but something tells me it was pretty easy when we do it out by ourselves.
Well, that's fairly common. And what do? You debug it and fix it. Right? But this is one way of sorting arrays. How long does this algorithm take? Depending on the length of the array, right? Imagine that we don't do this or this, right? Which were just for printing. How long does this min IDX takes? Takes about the length of the array. Does that make sense? How long the swap takes, that's a constant time, so I don't care, right? Now, how many times am I calling that min IDX? The length of the array, right? So if my array was of size 100, this is going to take about 10,000 operations, quadratic. If my array is of size 1,000, this is going to take about 1,000,000 operations. If my array is of size 1,000,000, this is going to take, in English, 1,000,000,000. Different languages use billion. In English, 1,000,000,000 is 1,000 million, and 1,000,000,000,000 is 1,000,000,000,000. In French, 1,000,000,000 is 1,000,000,000,000. And Spanish is all confused. Or at least in Mexico, we are all confused because we get, when people say 1,000,000,000, you don't know whether they mean an English billion or a French billion. It's in Spanish, it's supposed to be 1,000,000,000,000 too, like in French, but does that idea make sense? That is really cool. You can sort. You're going to spend the whole semester doing this. No. Looking at more algorithms and more ways, not the whole semester, maybe a month, looking at different ways of sorting. But this is one of the standard ones to do. There is another one, which is the coolest algorithm ever. Now, but it's a really cool algorithm. Binary search. And it is incredibly simple and elegant, and you probably know how to do it anyway, right? You just don't know how to put it in programming. If I tell you to guess a number, I'm going to think of a number between 0 and 100. And then once you tell me, I'm going to tell you high or low. Guess a number. I'm thinking of a number between 0 and 100. Tell me a number. Tell me a guess. 50. Higher.
75.
75. Higher.
90.
90. Lower.
85.
85. Lower. Yeah, two people got it, 2 people haven't got it yet, right? What's the best way you can do? Divide the range that you have by 2, right? So the first one is 50, right? So you're either, it's high or low, but I eliminate 50. I eliminate half my range. Next one, right? I said higher, so 75, right? Next one, and either you didn't get it or you're too lazy to do arithmetic, right? The next one should come in something like 87 or 88, right? Because that way you eliminate half, right? You have a range of 25 and you want to eliminate 12, right? Then the next one would be half of those. Does that make sense? So at every stage you're eliminating half. Does that idea make sense? When you have a sorted array, you can do the same thing. If you're trying to find a number in a sorted array, I can just go to the half, to the middle of the array, and then decide whether to go up or down. Does that idea make sense? So the easiest way is to do it recursively. I have a couple of things. If actually, let me do it this way. I'm going to search between from and to, right? We just need to be careful. If from is greater than 2, that means that I have messed up, right? which means I'm searching in the array between from and to, right? So between 0 and 10 or something like that. If I end up with somebody telling me between 11 and 10, that means that I've messed up. So I couldn't find it. Now, let me do this. Int mid equals from plus 2 divided by 2.
What? We should really go do the first one. The first if. Because once you say if from and to, no matter what, it's gonna start from the lowest number.
Well, we're gonna be changing our from and to, so eventually we'll end up with a wrong range. So we find the middle, right? Now, if ARR of middle, and I need the element. If array of middle is the element, we return true, right? Greater than element, the middle is greater than the element that I'm looking, so I need to look below, right? So I look between from and mid minus 1. Not I do between mid plus 1 and 2.
If we bypass the else if, and then on the if we use if mid equal, greater or equal to element. So it shouldn't return that one.
Well, the problem is that we would never return true then, right?
Okay. Yeah.
We need to say I found it, and that's true, right? That's what this one does. So this is a complicated recursive function. I end up with having actually four pieces.
Can you run it?
We can try. Sort numbers, we sorted it, right? By the way, arrays are objects, so they're passed by reference. When I call sort, I actually sorted the array. So let's do,
So you only have to call sort once.
it stays sorted, yes. Print line, let's do contains in search numbers. Let's find the element 25, which is not there, between 0 and numbers dot length minus 1. That should return false, right? So that should print false. Probably have not. Just my parentheses?
Take a
Yeah. I'm gonna do the same thing, but now let's find a number that's there. How about 5? Now let's run it and pray. Yay, it worked. These kinds of things are not supposed to work. Normally you would mess up and then have to go debug and print and figure out what's going on, but it happened to work because we're lucky. Does this idea make sense? Binary search is another one of the standard algorithms. How long does binary search take? if my array has 100 elements ish, right? How many times do I have to guess, right?
Maybe 4 times.
Actually, a little bit more than 4, right? What is the worst case scenario? That the element is not in the array, so I have to do all the guesses, right? So you would do 50, let's keep going down. 50, 25, 12, or say,
6.
yeah, 6, 3,
No, 3, that's it.
1. I still need to, so 6, 7, something like that, right? 2 to the 8 is 128. So actually, we kind of took advantage of the numbers rounding down to actually do a little bit less. So it's 7 or 8, something like that. If I have 1,000 elements, I need about how many things? Only about 10. 2 to the 10 is 1024, right? This is the logarithm base 2. If I have 1,000,000 elements, how long does this take? 1,000 takes 10, 1,000,000 takes 20.
Oh, yeah.
And a billion, an English billion, 1,000 million takes only 30. Isn't this amazingly cool? Once I have sorted my things, but binary search and in general, logarithmic algorithms make your life so much easier if you can. But you cannot always do these things. But when you can, it is really cool. And I think that's it for today. On the notes, there's also how to do arrays of objects, which are fairly similar to what we have done today. And your assignment has you do a bunch of these kinds of things, and then another one where you write a class that contains an array of things and do simple things with them. Because now you know about classes, so we are going to keep practicing classes every assignment. And I will see you guys eventually. I'm trying to stop this thing. I don't know how. Die. You can die. Yes, exit Eclipse. Die, die, die. Sorry. What the heck happened to this guy? Stop sharing. That will probably work, right? Why isn't this thing? Perfect.